Okay, today we get to do something super fun, permutations. This is our third day for the probability unit, and we get to do this permutations. So I have a little picture you don't have to draw, but we have these three little Bronco riders. They look like they could be at a rodeo, right? I wanted to just start with a little intro, so you don't have to draw them, but imagine if I needed to have, let me move away from the Broncos for a second. This worked better with the other class. If I needed to have three students help me take a bunch of stuff to the upper field, and I came into this class and I just grabbed three students, right here, Jimena, Bailey, Casey, I just grabbed them. Does it matter the order that they're in when they carry my stuff to the field? No. So I could start with Jimena and then give her some stuff and give Bailey some stuff and then give Casey some stuff. Or I could start with Casey and give him some stuff. It doesn't really matter. It just all needs to get to the field, right? So we call that little group of three that I select just a combination of students. The order does not matter. Permutations is something different. What if I had those same people? Jimena is A for her last letter. Bailey is B. And Casey is C. It's perfect.
But he's not.
Except for A. Oh, you're not Casey?
But his last name.
Well, let's imagine. We'll imagine. Oh, his last name is C. Okay. So Jimena, Bailey, and Casey Cowan. There we go. So here we are. They're at a rodeo and they are competing. And so they're the top three. And so does it matter the order that they finish?
Yes.
Does it?
Yeah.
Okay, so if it does, then I guess we could finish just the way you see here. We could have Jimena in first, Bailey in second, and Mr. Cowan in third, right? Or we could have any other arrangements, right? We could go the opposite way. Casey's in first, Bailey's in second, or Jimena's in third. Or how many different ways could they be arranged?
A, B, C, B, C.
You hear what you're doing?
6.
Very good. Very good. Look at this. Okay, let's start with Jimena. If Jimena was first, we could have then Bailey and Casey, right? If Jimena was first, we could also have Casey, then Bailey. So there's how many combinations or how many arrangements? There's two. Now let's go with Bailey. Bailey could be first, and then we could have Jimena, Casey, or we could have Bailey with Casey second, Jimena third. That's four combinations now, or four arrangements, I should say, right? Now Casey could be first with Bailey, Jimena in that order. That's 5. Or we could go Casey, Jimena, Bailey, and there's 6. So it looks like 6 total arrangements, right? The way that we're just doing that, and what you all were doing in your head trying to figure that out, is 5th grade style, isn't it? We're just kind of trying to make a little list somehow, which we can easily do with 3 people in a finishing positions of first, second, third. That's not hard. But when we get a larger question, like for instance, Irish dance, you have 150 dancers who are finishing. Maybe only the top 50 are placing, but would you want to make a list of how many different ways those 50 could place? 1 through 50? That would take you some time. So today we're learning a method for arranging objects in a particular order. Okay, arrangement is highlighted because permutations is a weird word for most people, and it's about arranging things in order. Tomorrow we'll talk about combinations, which is like my first example where I just need 3 students to help me move stuff. I don't care who finishes first, second, or third. I just need to move it, right? Think about in a burrito. Does it matter if I put in beans, cheese, lettuce, then meat, or can I do it in a different way? I mean, do I have to do it in a different way to have a combo burrito? No, it doesn't even matter. Just put it in whatever way and I eat it. That's it, right? But does it matter who finishes, first, second, or third in the Olympics and the 100-meter swimming? Does that matter? Yes, that matters. This is for when it matters, okay? The number of permutations, the way you arrange things, has a really tricky little formula, which we're learning today, which even includes a new math concept. And I'm just going to have you take it down and then we're going to practice using it. So the number of permutations is given with this, okay? So P stands for permutation, which think arrangements. N, sub N, P, sub R, so they're little subscript. equals, and with an exclamation point. Who knows what that means? Michael?
It's, I don't remember the name for it, but it means if n is high, you multiply it by 1, 2.
Good. And what do you call numbers that are being multiplied? The math term for that is? It begins with F. Factors. So it's about multiplication, and so this is called factorial. N factorial over the quantity n minus r factorial. So we'll put what these things mean down below. N is the number of objects. So in my example up here, I have 3 Bronco riders. That's the number. R is the size of the grouping. So the grouping I just gave you was first, second, and third. That's 3 places, right? So it happened to match up with the number of Bronco riders. But could I have 20 Bronco riders but only give 3 placements?
Yeah.
Yes. Okay, so that's possible too. And factorial is exactly what Michael said. If you have, let's say, 5 factorial, then 5 is a factor, and every natural number below 5, less than 5, is part of that expression. 5 times 4 times 3 times 2 times 1 is n factorial. Okay, let's try this. How many ways can you arrange all the letters in Eagles? Now, before today, a person, you don't need to write this, but let's imagine you're in 5th grade and you're trying to arrange the letters in the word Eagles. So you might just start with the word itself, Eagles, and then you might say, okay, I'm going to leave the E where it is, and I'm just going to start moving the other letters around, right? Like I could move the A to the very end and go E, G, L, E, S, and then put the A on the end. And then I could kind of follow that same thing, put the G on the end now, and say E, L, E, S, A, G, right? Now, is a 5th grader this systematic? No, but I feel very proud of my 5th grade skills. I'm being so systematic here. Move that L, E, E, S, A, G, L. And I got to keep going, right? I got to move that E, S, A, G, L, E. And now if I move that S, that second S, I'm back to where I was, right? So I'm not going to do that. I might start at the top again, but now I'm going to move the E to the N and start with A, G, L, E, S. Oops, I forgot my L. E, right? I mean, there's so many ways we can do this, and I would have to systematically try to create a list, right? And then, do you ever really feel safe when you do this? Don't you always feel like you might have left something out? Or did I double it up, you know? Did I double up somewhere? You go back and you search around and see if you did. So this could take you a while because we're about to find out actually how many ways we can arrange the letters in the word Eagles using what we just learned, okay? So here we have our formula again. We have a certain number of, N is the number, right? A number of letters in the word eagle being permutated or arranged in groups of, they're not limiting our group size, it sounds like, right? So we need to follow what we've already learned. We have n factorial over n minus r factorial. So who can fill that in and tell me, what is the n factorial? 6. Okay, so we have 6 letters in the word eagles. And we can arrange all 6. So we actually have the number 6 in both places here. We have 6 letters in the word eagles, and we're arranging them in groups of 6. Okay? So we start to plug in what we know. What will be the numerator? 6 factorial, right? 6 factorial over. Just use what the guideline says, right? 6 minus 6. What is 6 minus 6?
0.
So we end up with 6 factorial over 0 factorial. You know what 0 factorial equals? 0 factorial, guess what? Does not equal 0.
6.
Guess what it equals?
1.
1. Okay? If 0 factorial equaled 0, what would we have there?
Undefined.
And then we would be done. We would have undefined and we would be done. So for one of the reasons why 0 factorial doesn't equal 0 is because in the permutations, look at it, ends up in the denominator often, and you end up with a 0 there, which equals 0 factorial there, which equals 1. Okay? So there we go. We end up with just 6 factorial, don't we? And so 6 factorial is, let's say it, 6 times what?
5 times 3
Times-
4 times 3 times
I want to hear the whole class. 6 times
5 times 4 times 3 times 2 times 1.
There you go. Okay, that's all we have to do. Rather than try to create these arrangements, 5th grade style. Okay? And when you're multiplying these factorials by hand, use your, what do you call this property? What do you call that? No, that's not. That's not distributive. That's not commutative. Associative. Associative. What is 6 times 5?
30.
And what is 30? What is 4 times 3? And then we have 12 times 2, and the 1 is just silly. What is 30 times? You want to use commutative or associative?
Associative.
Okay. What is 12 times 2?
24 times 30.
So now we just have 30 times 24, which is 3 times 24, times 10, right? A place 5. So what is that? 3 times 24? Sophie?
72.
Say it.
720.
72 times 10 is 720. There you go. Did you know there are 720 ways to arrange the letters in the word eagles?
What?
So, would you want to do it 5th grade style? Or 7th grade style?
Easy.
Okay, let's make a new twist to the similar question here. How many ways can you arrange any 2 letters in eagles? Now, we still have all the letters of eagles, but we're putting them in 2-letter groupings. So like EA and AE, right? Or EG, GE, EL, LE, and so on. Who thinks there's going to be like 720?
No.
Who thinks there will be more than 720? Who thinks there will be less? Ooh, you are natural mathematicians. You have a natural. They think there will be less than 720. Who's able to put it down? Well, how does that work in our math? Anthony?
Well, you would need the number of the letters, which is
6. 6 is n. Okay, so 6 and permutated or arranged.
and then you would need R's too.
R is now 2. Very good. Very good. Okay, so follow your guide. And what is the factorial in the numerator? So, yeah. What goes in the numerator now? 6 factorial. Good. Over what? Very good. She says 6 factorial over 6 minus 2 factorial. Okay, so 6 factorial is 6 times
3
times,
times 2
and 4 factorial is 4 times.
3 times 2 times 1.
So this is what we have. So before you start multiplying the whole top and then the whole bottom, what could a person do right now to simplify your life? Very good. Multiplicative inverses. Do you notice I don't even have the ones on there?
Yeah.
Do they make any difference at all in the math? No. So look at 2 over 2 equals 1. 3 over 3 equals 1. 4 over 4 equals 1. These are multiplicative inverses. So how many arrangements? 30. Very good. Okay, good. So this is what you're going to do in your assignment today. Just things like this. Some of them are given to you as an actual 6P2, and you just do it. And there are a few problems on the second page where you are given a scenario, like how many ways can you arrange the letters of eagles. You have to come up with the permutation. So there you go. Have fun.